let's find a solution of this initial value problem. In this case, the solution, the general solution is the general solution of the homogeneous plus the particular solution. To solve the homogeneous, we need to make the non-homogeneous part, which is this part, we have to make it 0. And then we need to solve this differential equation, dy dt equal to 2y. And it is well known that the general solution of this homogeneous equation is c1 e to the 2t plus the particular solution. Let's see how do we look for the particular solution. We need to take a look at the non-homogeneous part, and we need to look for something like yp equal to an a e to the 2t because of this part. And even though there is only a 4t squared, we need to include all the derivatives. This is to be considered as a polynomial of order 2. Then we need to add here a b t squared plus ct plus d. We need to check if we need a second guess. To do that, we need to look at the solution of the homogeneous, which is this part, and we notice that this part is a multiple of the solution of the homogeneous. Then this part needs a second guess. That means that I have to multiply this by t. Then now we do what the differential equation tells us to do. The derivative of the function, the derivative of this function is, we need to do the product rule for this part, is a e to the 2t plus 2at e to the 2t plus 2bt plus c. We want this to be equal to 2 times the function, but the function is at e to the 2t plus bt squared plus ct plus d plus e to the 2t plus 4t squared. Let's see if everything is correct. The part that has the t e to the 2t must cancel. Let's see, here we have this here on the left, and here we have it when I multiply this by this. These two parts cancel. Then essentially what we need to do is to compare coefficients and get a system of equations. Notice that we have 1, 2, 3, 4 unknowns, a, b, c, d. Then we need to set up 4 equations. Then let's do that. The coefficient of e to the 2t, when we look at the coefficient of e to the 2t on the left, is equal to a, and on the right is a 1, right? 1. The coefficient of t squared on the left, there is no t squared on the left, then it's 0. And on the right, here we have, when we multiply this by this, we get 2b. The coefficient of t, is 2b plus 4. Right. The coefficient of t on the left, is 2b, and the coefficient of t on the right, when I multiply this by this, I get 2c, and there is nothing else. And the constant coefficient on the left is c, and on the right is, when I multiply this by this, is 2d. That means that a is equal 1. From here we get that b is negative 2. From here, b is equal c. C is equal to negative 2. And d is c over 2. Then d is equal to negative 1. That means that the particular solution is going to be a, which is 1, t e to the 2t plus b minus 2t squared plus c minus 2t plus d, which is minus 1. This is the general solution of this differential equation, but now we need to take care of the initial condition. Let me erase this part. We want this function, the general solution, to be 0 when t equals 0. Then by replacing, remember this is the general solution, I'm going to replace t by 0 here. I get c1 plus 0 minus 0 minus 0 minus 1 equals 0. And that means that c1 is going to be equal to 1. Then the solution of the initial value problem is c1 is equal to 1. Then you have e to the 2t plus t e to the 2t minus 2t squared minus 2t minus 1. Okay, this is it for this video.